Okay, so let's start by factoring this first one how we would normally. Now, normally when we factor, we have three pieces, right? So the three pieces are still here. It's just that the middle piece, okay, is 0. So when we do our little puzzle, we're trying to find two numbers that add to 0 but multiply to negative 64. Okay? Now, if they add to 0, what do we know about them, guys? One's going to be positive, one's going to be negative. Good. And what else? Same number. Good, Alex. The same number. Okay? Which is good if I want it to be the same number, because doesn't 64 have a perfect square? 8, right? So if I know that for our puzzle, my answers are 8 and negative 8, then that tells me, remember that pattern you guys noticed? Or should I, here, I'll still do the box. Then I've got x squared, negative 64, 8x, negative 8x, and then I'm going to pull out my GCFs, and I know that this factors into x minus 8 times x plus 8, okay? Now, on ones with binomials though, okay, where the middle term is 0, I don't want to have to do that work the whole time. Don't I like shortcuts, right? Anybody have any guesses how this one's going to factor? Mandy?
Is it just going to be like x minus 5, x plus 5?
Yeah, can you explain where you got that from?
Because 5 times 5 is 25.
Okay. What else? Oh, that's a good question. Can you put x minus 5 to the power of 2? Let's talk about that, okay? If I can't distribute a squared, right? So this being multiplied out would be x minus 5 times x minus 5. Now, if I multiply that out, notice that my middle term isn't going to add to 0, right? It's going to be negative 10x. For it to add to 0, one has to be positive and one has to be negative. Okay? Good. What else? Okay, someone from this half of the class, I want you to take a guess what you think the next one's going to factor into without having to do a bunch of work. Today's all about shortcuts. Okay? Someone from this half of the class. Take a guess what the next one's going to factor to. Seven? Okay, so just 7? No, that's a good guess, Trista. You're right there. She knows there's got to be a 7 involved. Someone else help her put it together. I want over here. We got to put a negative in one and a positive in one. So does that mean this one just factors into 7 times negative 7? Ah, I need the x's. Okay. Hudson, can you read to me what you think it would be?
X minus 7 times x plus 7.
You got it. Now I can go through and do the box if I want, right? But today's about shortcuts, okay? Okay, yes, Victoria.
Isn't it just for the negative 49, you just do like whatever two numbers are these are two less numbers, and then put a negative in front of it.
Yes, exactly. Now what is that called, guys? When she said just find whatever two numbers multiply to the 49, what is that called? Factor. Keep going though. There's a special case when I'm looking for the same two numbers. Forgot my math word. What's that called? What? Square root. Good. Now, I'm not square rooting the negative 49 though, because if I were going to square root the negative 49, it would be 7i. Good, Gavin. So I'm pretending the negative's not there, right? And I'm just square rooting the 49. Does that make sense, guys? That's important for what we're going to do in a minute. Yes?
What if there's nothing
Can you talk louder, Victoria?
what if it's an uneven square root?
Ah, then we'll have to do our factor trees like last unit.
Okay.
Okay, and we'll get there. Okay, let's go through these other ones kind of quick. Okay, x squared minus 1. Can someone raise their hand and tell me what the factors would be? Someone raise your hand and tell me what would the factors be? Someone raise your hand and tell me, how does that factor? Victoria. Okay, so just 1 times negative 1? Michaela's trying to help you out, Victoria. So close.
I'm sorry, x plus 1 and then x minus 1.
Perfect. Good job. Okay. Next one. Someone new. Someone new. Is this easy? Okay, then tell me.
X plus 81. X minus 81.
So close. What'd she forget to do to the 81? Square root it, right? What's the square root of 81? 9. So x plus 9 times x minus 9. Okay, now that we've picked out the pattern, let's try the questions below. But what do you think you need to look for first?
The exponent. Make sure that you only take out 2, like, it has to be like 5 times 9 instead of like 5 times 5 times 5 or something.
Okay, look at the exponent. That's good. Okay, what else do you need to look for?
A denominator to simplify it.
Denominator to simplify it. What's our vocab word for that?
C?
What?
The GFC?
GCF. You got it. You got it. But that's perfect. Greatest common factor, which is our denominator to try and pull it out, right? Okay, so let's look at A. Okay? Is there a GCF?
Yes.
Not on A.
Oh, for the second one.
Okay, but we're on the first one. Not on the first one, right?
Yeah, I meant like you can square root it.
Oh, you can square root it. Okay, it is going to be a perfect square. What is the square root of 121?
11.
11. Okay, so then my factors would be x minus 11 times x plus 11. Now, we haven't done one like B yet. First, is there a GCF on B? Is there a number that goes into 9 and 25? No. Okay. Does anyone have any guesses what this one might factor into? Because this one's a little different. This one's different because there's a number in front. 9 is still a perfect square, though.
Would it be like 3 and 5?
What do you mean 3 and 5?
Well, both of them are perfect squares. There's no greatest common factor between the two.
Okay. So are you saying the factors are like x plus 3 and x plus 5? Is that what you're saying?
Kind of like with the 9x squared, that can go in 3x, and then the 25 would be 5 in common.
Okay.
I'm not sure.
Gavin's really close. Yeah, Alex.
It would be 3x minus 5 and 3x plus 5.
Where did you get those numbers, Alex?
The 9 and 25.
She square rooted them. Perfect. Okay, I want to show you guys that works still. Okay, we're still square rooting each piece. Now, we're not square rooting the negative with either piece, right? Because if we were, we'd have an I in the situation, right? So the negative is just what tells me that I know one needs to be positive and one needs to be negative. So when I multiply them, I end up with a negative number. 3x minus 5, 3x plus 5. I just want to, you don't have to write this out. I'm just showing you that it works. So I end up with 3x times 3x, so that's 9x squared minus 15x plus 15x minus 25. Look, these are going to add to 0, right? These cancel, so I'm just left with the 9x squared minus 25. Okay? Is there questions on that? Okay, is part C the same thing? No. Why? What's part C? There's a GCF. What is the GCF? 2. Okay, so let's get rid of that 2. Now look at that. I have a nice, perfect square to deal with. What's the square root of 100? 10. So my answer is going to be 2, x plus 10, and x minus 10. Okay, what about D? What about D? Is there a GCF? Michaela? You got it. If the first one's negative, that's the GCF. So let's get rid of that negative. And then I can factor it.